Hello space enthusiasts, I'm back with another failure analysis, and this time we are heading to Mars. Yes, we are discussing the blade failure in NASA's Ingenuity helicopter. I've checked the evidence and images closely. For me, it appears more likely that the blade broke due to fatigue, not a ground contact. Stay with me for more details. First, an overview of the cameras on the Mars Ingenuity. One camera, known as a navigation camera, captures black and white images from beneath the helicopter. The other camera, positioned on the fuselage, delivers colorful and high-resolution images is called color camera. It is also important to mention that one leg of Ingenuity differs from the others, consistently visible on the left side of the images of the color camera. We can also catch a glimpse of the tiny part of the right leg in these pictures. I named the legs in this order, that the different leg as 1, and the rest is named 2, 3, and 4 as seen in this picture. Let's analyze the first image showing the scratch on the surface. It's possible it resulted from blade contact, but let's think it through. If the blade did hit there, it would have definitely kicked back Ingenuity, and in this slope, it's more likely it would have rolled downhill afterward due to the impact. Now let's consider the design of those blades as they are in different height. For both to hit the ground, Ingenuity would need to be almost level or tilted just like the hill slope. How probable is that the Ingenuity tilted extremely, hit the ground, and miraculously got into the upright position with 2 damaged blades and landed perfectly in the same place without rolling? For me, it seems unlikely. But share your thoughts in the comments below, and there is still more to unpack here. So, about the reason to damage the blades. It's made from foam and covered with carbon fiber, but compared to space alloys, they are not exactly built to withstand tough conditions, especially against radiation. Now imagine this. Ingenuity is out there facing the Martian winters and those crazy temperature swings. But with all that thermal expansion going on, it's like the blades getting a real workout. And let's not forget, every time Ingenuity takes off or lands, it's like it's constantly bombarding with sand and rocks. Plus, spinning at 2500 RPM, that the blade's dealing with some serious force. So it's no wonder cracks start to form and things start to break. It's a real challenge for a little guy like Ingenuity. Now, let's zoom in on this picture and observe something interesting. 2 small pieces that appear to match the color of carbon fiber, which could be separated from either the blade or the legs. It's like a little puzzle piece that tells us the left leg was there before. Before going to the possible mishap scenario, if you like, please like this video and subscribe to my YouTube channel. In Mission 71, Ingenuity encountered obstacles during its attempt landing on sandy terrain. Issues arose with image processing exacerbated by a brownout phenomena commonly observed on Mars, where sand kicked up during landing and impairs visibility. The bombardment of sand likely resulted in the loss of a small section of one blade, leading to instability during landing. Specifically, scratches on the ground visible during Mission 71 attest to these challenges. As we cannot see the horizon in the color camera image, it is probable that Ingenuity landed during Mission 71 with the camera not oriented toward the top of the hill. Furthermore, there is significant excavation observed on the ground from leg 2, while scratching on leg 1 appears minimal. This discrepancy suggests a potential issue with one side of the helicopter. Such observation can be important in determining the direction of landing for Mission 71. Upon scrutinizing the image captured on February 25, 2024 from the Perseverance rover, 2 distinct scratches on the ground are visible in front of Ingenuity. Interestingly, there are no corresponding scratches underneath Ingenuity visible in this picture. The depth, length, and spatial distance between these scratches appear to align with the position of Ingenuity's 2 legs. Additionally, the presence of another leg is evident in a separate picture from the navigation camera. This suggests a possible landing scenario for Ingenuity during Mission 71, particularly when considering the orientation of cameras facing toward the direction where Perseverance is located. During Mission 72, Ingenuity faced challenges with a damaged blade and insufficient power. However, the log file indicates an ascent to a height of 12 meters, an unusually high altitude for a helicopter with a damaged blade. Considering this, it is possible that Ingenuity attempted takeoff but struggled due to power limitation. After this attempt, another brownout occurred during landing, resulting in an unstable descent. The initial landing attempt resulted in a significant scratch and the loss of another blade. Following an automatic takeoff, Ingenuity ascended only a few centimeters before landing again with instability, leaving an extended landing footprint. These observations suggest that the two scratches likely originated from this uncertain landing, exacerbated by Ingenuity's unstable condition. Now, let's explore a significant observation. You see, with those blades spinning in opposite directions, it's quite fascinating that we found one blade about 200 meters away from our little Ingenuity. But here is the point. It is entirely possible that the second blade might be somewhere within the same 200-meter radius. Let's step back to Mission 71. The damage on the first blade was probably very small. Nothing too serious since Ingenuity can fly again for the last mission. So this small piece on the right side of the picture with the distance around 200 meters away from the Ingenuity can be the first part of the broken blade. Now in Mission 72, a much larger chunk of the other blades separated and landed about 200 meters away on the left side of the Ingenuity, as you can see in this picture. Unfortunately, when Perseverance came to visit on February 25th, Ingenuity found itself facing the opposite direction, unable to catch sight of its only companion. Ingenuity was left alone in the Martian deserts. For future helicopter missions on Moon and Mars, it's crucial to consider the accelerated development of fatigue stress and cracks in the blades. Additionally, measures should be taken to protect the blades from grinding by the surface sand. While the autonomous takeoff and landing systems perform well, it is wise to include the potential impact of brownout during these maneuvers. I hope this analysis, based on publicly available data, proves beneficial for future Moon and Mars helicopter mission, and I wish NASA success with the future endeavors. Thank you for watching this video, and I will come back with another space failure analysis.